All right, our next panel session is entitled Future Fuels on the Road Today. And I'm pleased to introduce Rick Sykes, the moderator of our next section. Rick's the COO of Carbon Blue, a company dedicated to assisting fleets with managing costs and emissions. And before that, he was the fleet manager of the city of Santa Monica. A really nice guy and a person that I'm proud to call a personal friend. So Rick, if you'd like to come on up and get this panel started.
All right.
Good morning.
Good morning.
So this is great. We've been involved with All-Car for a long time and been up here for all three of them now. And love to see all this activity going both in the north and the south, and like to see it going in some other places too. The panelists that we have today are working in the future of fuels and technology and what's going to be on the road in the future. A lot of it's on the road today already in demonstration projects, or some of it's very commercially available and they're ready to sell it to you. We're going to have four panelists. We're going to talk. They're going to each talk about 10 minutes, and that should leave us about 20 minutes for Q&A, if everything goes according to plan, right? Which it never does. So the first presenter is Clay Collier. He's a co-founder of Keeson. It's a software company dedicated to integrating both mobile and stationary energy storage to support the grid. Clay has patented multiple technologies in the areas of geospatial technology, energy systems, and software, and they include car navigation software, location-based system application for smartphones, and the full suite of software and hardware created for the automated demand response market. Clay's also managed the largest vehicle-to-grid fleet in the world at the LA Air Force Base, and led a team that created the suite of software that enables the integration of EVs to support the grid and as operational assets. So welcome, Clay.
Thank you. So we're a software company. It's Key Sensum. Key is Earth, Sensum is awareness. Our focus is explicitly software that enables grid balancing and the integration of energy storage, in particular electric vehicles first, and any form of energy storage to accomplish that. I'll start without slides. So we're the software company that is responsible for the software suite at the LA Air Force Base. And how we got into that was that we had developed what's called Open ADR, Open Automated Demand Response, which is a demand balancing software at a company, Akuacom. Oh, great, okay. And by the way, key phrase, on the road today. I'm happy to say I'm going to show you pictures of stuff that's really working on the street. Some of it Tim Lippman talked about earlier from the academic research perspective, so I'm happy to say you'll see real stuff working. All right, so our background, again, we developed OpenADR, which was a demand response balancing technology conceived by Art Rosenfeld of California, and it led to OpenADR being the open protocol rolled out around the world. We were acquired by Honeywell, and we were working on a gateway for the LA Air Force Base, and we exited and started Key Sensum to do this. So happy to say, in starting this company, right away we had Department of Defense and Department of Energy funding and focus to do conversion of internal combustion engine fleets into electric vehicle fleets. So we started working with Lawrence Berkeley Labs and the team of car vendors, people inventing the technology. So we immediately were able to gather an ecosystem of very active, motivated participants and get some projects done. The LA Air Force Base. So here's a picture of real cars that are used on real assignments, managed by a fleet management system software that facilitates the integration of those as a grid balancing aggregated asset. So I've got 42 vehicles. Some are trucks, pickup trucks, vans, buses. You see a bunch of Leafs on the left side. And what we do is when those vehicles are at their charging stations, they're all two-way charging station and two-way battery control, I can trade the energy for the batteries in the ISO market. So I can actually make money from the cars in the CAL-ISO frequency up, frequency down market. So again, it's 42 vehicles that are hooked up to chargers in the two-way implementation. And delighted to say with the participants, the DoD has been great to work with. Carmen Gorgonpour invented this concept, but it's real world, it's out there. And what you see, the graph on the bottom, is the actual trading in the market, where the CAISO will say, I want your collection of batteries to go up 10 kW, down 100 kW, up 10 kW. Those are 4-second intervals. And so I can make money in that market because batteries are very quickly responsive, and the ISO loves fast responding balancing assets. Software suite, we didn't eat lunch yet, so I get to talk software. So we developed this suite of software that does the fleet management all the way to the ISO trading. So what that means is if a general wants to take a car from the LA Air Force Base, which is Space Command, over to El Segundo, and then the LA Air Force Base, I'm back, I know the mileage. I know exactly what the state of charge is. I know what it will be. So I get to know all 42 vehicles, exactly what those batteries will look like 24 hours in advance. I know what the mileage is. So I can make a bid. I can bid to the CAISO market and say I can give you 200 kW completely available to you to go up and down at 4-second intervals. So I can get paid to participate in that market. But that means I have to have an integrated suite of software that does everything from scheduling vehicles in and out to bidding into the ISO. So I have to conform to the ISO requirement. I have to do the actual charge control, which is the real quick up and down across all 42 batteries to make them into the right state. And I have to guarantee mission capability in each of the cars that we use. Mission comes first. So that's the suite of software that we developed specifically originally for the LA Air Force Base, but those modules are all reusable in different real world applications. So obviously this all starts with fleet management. I'm a big fan of fleets of electric vehicles, partially because they're owned by one entity, and one entity can agree, sure, I'll provide my 20 cars or whatever I have as an asset that I can make money from, and they'll all be in one location, so I have a good location to trade from. And if it's a fleet, it can be scheduled. I can know what time it's going to go in, go out, I can monitor it, and I can know the state of charge of the batteries. So this, to us, this market will hopefully evolve through fleets and then into widely dispersed assets of individually owned cars. Now, there are a lot of, I'm happy to say there are a lot of electric vehicle manufacturers now. And you see that some of the big boys in the industry, we just, one of the speakers talked about the General Motors, they have the Bolt, that's great. So if you look at the preponderance of the number of models that are coming out, that's impressive. And then you apply this, that little green bar there is an anomaly called Elon Musk is a good salesman. It just distorts the whole concept of the market. He pre-sold, and it's now about 375,000 cars. And if you heard the description of the General Motors Bolt, it's the same car. It's a $35,000 car with 200-mile range, and it's available today. So, I think Randy was probably intelligently cynical in saying that we're still going to be at 3 or 4% of the overall used fleet in 5 years or 10 years in California. Maybe, but hopefully, there will be an anomaly in rapid growth, and we're going to hit our 1.5 million in California. So I think the concept of the electric vehicle fleet is going to be well supplied by this market. Now, we reuse this technology. So again, we know how to interface to the electric vehicle scheduling. We know how to use energy storage. We understand demand response. So at UC San Diego, we're working with EVgo, which was owned by NRG. It's now part of Vision Fleet Capital. And they're doing static batteries to balance the need, how you charge. If I'm charging 4 cars at a time, I'm gonna have a spike in demand. So we can use static storage supplemented by solar to balance that and alleviate the demand charges. And EVgo is one of the biggest, actually at the moment, probably the biggest network in the US. And we're happy to say they're gonna roll out fast charging using static storage. So this is what, if you had a meter on a charger, on a DC fast charger, this is what 15-meter data would look like across a period of a month, if you take each day at a time. And if you look at that purple bar, Everything above that purple bar becomes a demand charge that gets applied to my entire month's electricity bill as a multiple. So what I really want to do is I want to cut that. So if I use static storage, and I know the right amount of static storage to stay below that, that's how much money I save. So I have a very direct return on investment calculator that can be used to say, wow, if I'm going to charge, if I have 8 DC charging stations, I need this much battery to cut my cost in half. And the margins at this point are razor thin for these guys doing charging stations. We're also happy to work with Alameda County, ChargePoint, LBNL on a project to do V1G, which means just optimize, do smart charging. Optimize the way that chargers are used, how many vehicles get through them in a day, and optimize the reduction of the demand charge. So again, the idea is the peak, if you take EV charging plus building load, and you look at that high peak, that's the penalty you pay in a month. And our job with our software is to take that down and reduce the charge. All right, so I just flew through a lot of technical stuff. Happy to answer questions when you get to it, but in a synopsis, we started with the LA Air Force Base doing fleet management, charge optimization, and trading in the market. We can use those same technologies for demand response reduction using static storage and or simply smart charging with the assets that we have. And again, happy to say this is real world fleets being used by the Air Force. And we're big fans of the future of fleets. All right, thank you.
All right, next up is Jorg Ferchow. He's the CEO of Efficient Drivetrains. Did I mess that up, or is that right?
That's perfect. Thank you.
It's the way it's spelled. For some reason I thought it was pronounced differently. But so, since 2006, Jorg has been the leading EDI's creation, development, and commercialization of complete hybrid and electric drivetrain solutions, continuously variable transmissions, and drivetrain software for leading automotive manufacturers worldwide. Previously, Jorg served in executive leadership CEO positions in successful startup ventures in large corporations such as GE, Tandem, Compaq, and SanDisk. Reflecting his passion to clean the air for a healthier planet, Jorg has created many world's first concepts that are helping the world's largest automotive brands solve their toughest challenges, such as the utility truck solution that reduces emissions and fuel consumption by up to 80%. Welcome, Jorg.
Yeah, thank you. Well, good morning, and thank you all for being here. I'm going to talk a little bit about some technology, some really exciting, innovative drivetrain technology that radically changes the performance of vehicles. But the other part of the equation really is the alternative fuel choices that we have and how you combine those with vehicle technology. And for me, I always like to think about what's the motivation, why are we working in all of this technology and all of these alternative fuel things. And the motivation really comes down to a lot of different things. Over the last 10 years, it's been things like just passion for the environment. Then it was fuel cost when we had $5 a gallon fuel cost here in California. Everybody was paralyzed and things stopped. Then it was energy security where we had rationing of diesel fuel and things like that. And then after the economic downturn, it was about job creation, just local economic growth. And now it's more and more about greenhouse gas reductions and global climate change. But the thing that I've seen change the most, and I'll get into technology in just a minute, but for me this is my motivation. What I've seen change the most in the last year and a half are all the new concerns about our health. I mean, our health and our children's health, and it has to do with the number of days and the level of pollution we have in our air. So whether or not you agree with global climate change issues or other things, there's no one here that would argue against the need for cleaner air. And that's the mission that we're all working on, and that's why our work is so important. California Energy Commission, they have tracked air quality. They're saying that 90% of Californians are breathing unhealthy air more than 100 days a year, particulate matter and ozone. And California, where we all live, it's the 9th largest emitter in the world. So we all have a big obligation to clean up our act here. And again, it's not just about the fuel choice, it's about how all the fuel is processed, where it's sourced, it's the entire production chain, all of that produces emissions. So again, that's our motivation and our mission is, it's up close and personal now, it's our own health and the health of our families. So more about what EDI does. We're focused on developing drivetrains that radically alter the performance and the emissions of a vehicle. And we create what's very unique, world's first 4-mode drivetrain. And the way these drivetrains work is that once they're installed into a vehicle, you plug it in just like a normal electric vehicle. You get in the car in the morning and you drive it as a full zero emissions EV with full performance in the city and on the highway. And it's an EV for all practical purposes. And then if you get to a hill or a mountain or a ramp and you need more EV power, we can actually use a second motor and combine the power of 2 motors and give you what we call an EV plus mode. So you can use 2 motors, get up a hill, get up a ramp, and gives you a more powerful vehicle, but it also means that all the motors can be smaller and cheaper and lighter. After the battery energy is low, we run into a hybrid mode, but it's actually 2 different modes. One for city, it's a series architecture, and that's perfect and very efficient for low-speed stop-and-go driving. And then after you leave the city and you're on the highway, series is very inefficient, so we become parallel. So EDI's drivetrains is EV, EV Plus, series, and parallel. And we've developed those for all types of vehicles, everything from small sedans to SUVs, trucks, buses, and beyond. And again, the philosophy there is to build the world's best EVs, but to make those vehicles practical by having a second vehicle fuel source on board. And it can be anything from CNG to diesel to gasoline, propane, renewable natural gas, those kinds of fuel sources. So again, they're scalable, and here these are just examples that are running our drivetrains today. There's a bus on the top which is running in 3 cities in China, and we reduced emissions by over 50%. They've been in production for over 2 years now. We have a 100,000-pound port truck just below that that's being delivered for the Port of Shanghai this quarter. We've done plug-in hybrid CNG trucks. And then our top priority and major focus in the U.S. has been partnering with PG&E to support their vision for what a future work truck would look like. And I think Dave's going to talk a little bit about that. And then finally, the last bullet there is, once you have a drivetrain in a vehicle, it does cost more. You've got batteries, you've got motors, you've got lots of new technology that you're building in. We're also looking at how you can leverage that technology for other applications so that the ROI for the vehicle is better. So we do things like export power, we electrify accessories, and we have more things coming. Again, how we do that, on the top left, the idea is you start off with a normal vehicle chassis. And in general, what we do is we replace the automatic transmission with a very clever, very innovative motor system. So we install the motor system in the same hole where the transmission goes, add batteries, and now you have a vehicle that's a very strong EV, a parallel, and a series hybrid. And then on the bottom, you kind of see the 2 diagrams there. We also do a lot in the area of vehicle control and how you blend power between fuel sources to be efficient and minimize emissions, and add in telematics capability and real-time monitoring. And then finally on the top right, this is something that PG&E has really been the leaders on and provided vision on, and we've been very happy to support them, is the idea of exporting large amounts of AC power off of a vehicle. And we set records in the U.S. for the amount of power coming off a vehicle last year. So again, that's just a short introduction, and again, the mission is really important. We're all working on our environment, our health, our families' futures, all of those things. And like to say, the race to zero emissions is accelerating across the globe, and we all have a really important role in that. So thank you very much.
Okay, next is Pat O'Keefe. Pat O'Keefe is the Vice President of Golden Gate Petroleum. It's a 70-year-old family-owned wholesale distributor of fuels and lubricants, and he's also the CEO of NextGen Fuel. Pat has been instrumental in introducing biofuels to the California fuel marketplace. We started in '96 by making Golden Gate Petroleum one of the first and largest distributors of biodiesel and biodiesel blends in the nation. In 2013, Pat introduced the next generation of cutting-edge biofuel for fleet use in California and the U.S., known as renewable diesel, or RD100. Pat founded NextGen Fuel, offering renewable fuels while educating fleets, customers, and the public to its many benefits.
Thank you.
Welcome, Pat.
Hello, everybody. I'm here to talk to you guys a little bit about renewable diesel, just as a fuel itself, and then what we call as Next Diesel, which is essentially renewable diesel. So, what is it? I don't know. I mean, at this point, I've given this talk enough times. You might have already seen it, somebody. But one of the main points of this whole talk is what is this thing? If you've heard about it, this fuel. So, just kind of to run through it. It's a petroleum-free drop-in replacement fuel, but it can work in any petroleum engine, which is a very key point, without any sort of modification, any changes. It's also referred to as HDRD, it's hydrogen-derived renewable diesel, or HVO, hydrogenated vegetable oil, but ultimately what it is a second-generation alternative diesel fuel. It is a pure paraffinic hydrocarbon. It sounds fancy, but ultimately that's a very key point to what this means is, one, the purity of it. It's 100% paraffinic. And a paraffin is what comprises most of petroleum diesel, but not all. So essentially the way you could look at this is it's incredibly pure diesel fuel that's made from a renewable resource. But the fact that it's a hydrocarbon is kind of the game changer aspect of renewable diesel, and the fact that it's chemically and structurally identical to petroleum diesel. So you don't have any sort of operational or conversion type problems. Odorless, colorless, free of sulfur and oxygen, which I can show you in a little bit why that's a benefit. So, it's made from the same feedstocks as biodiesel. So I don't know if people have heard of biodiesel, but so you can start from the same exact feedstock, but you end up with a different product, which we'll see in a minute. Benefits. You can use it as 100%. That's what most people do, or you can blend it. It's being blended in small concentrations as well, but our company primarily sells it as a pure fuel. And you don't need to change any infrastructure to either the pumping, the dispensing type infrastructure, or the vehicle itself. But there's absolutely no need to change anything. You can use it the very next day, after you buy a vehicle. It meets ASTM D975. That's an absolutely very, very important point. And if anything you care about you remember from this conversation or this presentation, it's that fact. Because ASTM D975 is it's the series of tests that dictate what is diesel fuel. And diesel fuel, be it from a petroleum feedstock or from a renewable feedstock, if it meets that criteria, it's quote unquote diesel. And that's a big deal for a fleet, because your engine warranty is going to dictate the fact that it needs to, the diesel fuel to meet warranty needs to meet ASTM D975. It obviously also meets CARB diesel specifications. Very high cetane number. We're not a huge amount of time today to talk, so I'm not going to get into too much of that, but cetane is to diesel what octane is to gasoline. And so typical petroleum diesel cetane is 48 to 52 in California. So you can see it's dramatically higher, which there's a series of benefits, but ultimately it's a very, very high quality fuel. Very stable for long-term storage. That's good for a fleet. If you've got, particularly a public fleet, if you have equipment that you only use during storms in a winter time and it sits all year long, or generators, backup generators, or something like that, any sort of fuel that doesn't get turned over all that much, it's an excellent option for that. Obviously, a lot of what we're hearing today are great options as to how do we reduce our footprint of emissions as a fleet. And using renewable diesel is a very simple way to do that and to get a tremendous benefit of reducing your emissions. Primarily greenhouse gas emissions, CO2, depends on the feedstock and where the renewable diesel is made, but you're going to get a 65 to 90% reduction just by switching fuel, which is, unbelievable in regards to the amount you can reduce of your CO2 output or your carbon intensity. The tailpipe emissions, PM, NOx, CO, and HC, hydrocarbon emissions, are all reduced as well. That is a benefit more so in the off-road sector, where you don't have all of the after exhaust emissions cleanup devices that the modern on-road diesels have. but it's still obviously it's a cleaner burning fuel, puts less stress onto the equipment itself's DPF, if you're familiar with the diesel particulate filter. Low cloud point is good. In California, we don't typically see negative 20 degrees Celsius. At least I hope not. It seems to be the earth is warming, not cooling here. But that's good in the fact that you don't have any cold weather issues, be it the fuel can be used anywhere in the world. So that's it's a very good characteristic of the fuel. I mentioned this before, and this is very important for a fleet operator to for them to be able to use a renewable fuel is, will it void my warranty? And I've spent 3 years now selling this fuel, having the same conversation over and over and over again. And so it's in talking to the manufacturers, talking to the fleets, and so ultimately it will not void your warranty. If they say it will, then call me and I'll help you, because it will not. It meets the petroleum. It's chemically identical in its makeup, and it's essentially the carbon chain or the chemistry of the fuel is identical to petroleum diesel. So there's absolutely no way it can void an engine manufacturer's warranty if it is technically diesel. It just happens to be from renewable feedstocks. Some of the fleets, obviously, like I mentioned, we've been selling renewable diesel now. We kind of introduced it to the marketplace, and that was 3 years ago in April, so a little over 3 years now. And it's been I remember we were at the ACT Expo and we were showing all these curves, and it's pretty much, I think if you went over the last 3 years, it would almost be a vertical curve as to growth. It's been tremendously well adopted into a lot of the public and then private type fleets around. Let's see, so off-road vehicles, again, this is good for if you have, could be, construction equipment or tractors or sweepers or anything, because off-road equipment doesn't turn over as quickly as on-road equipment does. So a lot of times, and there hasn't been a retrofit mandate or even new equipment. It's just starting to come with Tier 4 type exhaust emissions reduction on off-road equipment. So if you need to lower your carbon footprint and or your tailpipe emissions, it's a great, just switching to renewable diesel is a phenomenal way to do that in your off-road equipment. That's the car outside. We drove that across country. It was 2,500 miles, and we used 38 gallons of Next Diesel, which was pretty. So we averaged 67 miles per gallon, but also about almost 70 miles per hour average. It was very hot, and we were trying to get there in a hurry. So we probably didn't help our fuel mileage that much. But the other kind of neat thing we're doing is, again, just these are. I've been racing something my whole life, so I'm able to combine kind of two passions, and so we're going to be racing in the Baja 1000 with just one of these a trophy truck using renewable diesel, and it's going to be the first time anybody's ever tried anything like that. It's got to be the most difficult thing to try to put a fuel or an engine through. So we're gonna give it our best, and that's in November. Next Gen, this whole presentation here was primarily driven to educate people on what is renewable diesel, because really that's the question we get asked all the time. But what Next Gen Fuel is really a company that we formed to not only focus on getting renewable diesel into the marketplace. That just happened to be our first fuel that we were able to determine that it's commercially viable, it's good for our customer base. So we brought that into this marketplace, call it Next Diesel, and that's been a big success. But we don't want to stop there. There needs to be a solution for the gasoline-powered engine as it relates to a renewable drop-in replacement fuel, renewable propane, renewable hydrogen, renewable natural gas. What we are is really the conduit from getting the fuel to the user. That's what we're experts at. So we help determine what's viable for the customer and then make sure that they have it available. Golden Gate Petroleum, we're a large 70-year-old family-owned business that I've essentially been there my whole life, and so we were the first people to really bring biodiesel into California in the mid-90s, and we were the first pretty much in the world to start selling renewable diesel as a fuel. So we're pretty proud of the accomplishments that we've had being in as a distributor of petroleum as our main business. We're proud of the fact that we've been fairly progressive as it relates to everybody else in the industry. So renewable gasoline and propane, I've only got about 40 seconds left, so we are working very diligently to bring these to market. Renewable propane is not such a difficult task. Renewable gasoline is a very difficult task, and so we are working hard that would have to be a longer talk to tell you where we're at. But we will. I can't wait for the day I can give one of these talks and actually say that, oh yeah, we're finally in testing of renewable gasoline. So that's it. If you guys, it's a very, very simple fuel to use. There's a lot of people already using it. I can see people in the audience here that are customers of ours, and we greatly appreciate that. It's great. So again, thank you everybody, and I'm happy to answer questions or talk afterwards.
Thank you. All right. Next up is Dave Micel. He's the Director of Transportation Services for Pacific Gas and Electric Company, PG&E. In his role, Dave leads PG&E's Transportation Services Organization and its more than 433 employees, where he manages a fleet of over 14,000 vehicles. During his tenure at PG&E, he has established PG&E as an industry leader in utility fleet operations and the integration of advanced transportation technologies. PG&E currently operates the largest alternative fuel fleet in the utility industry and one of the largest in the country. David and PG&E are committed to demonstrating strong environmental stewardship through the expanded use of CNG, LNG, hydrogen, as well as electric-based vehicles, including hybrids, PHEVs, and EVs. Welcome, Dave.
Good morning. I apologize for being late this morning. Our traffic in our local town wasn't conducive to travel this morning. Okay. I've got about 20 slides here, so I'm going to go relatively quickly, and I'll just make them available if people are interested. So if you look at PG&E, our service territory starts just north of Los Angeles, right about Santa Barbara, where we have natural gas, and goes really up to the Oregon border, from the Pacific to Nevada. So it's about 75,000 square miles. In order for us to operate our business efficiently, we are, somewhere, I keep telling people, I don't know exactly how many vehicles we have. It's somewhere between 14 and 15,000. We have a constant flow in and a constant flow out. And when you have a territory the size of ours, we only get to count them about once a year. So it's a moving target. When we look at our current state, about 35% of our power units are alternate fuel based. We do use a combination of different forms of electricity, whether it be full battery electric, plug-in hybrid, electric PTOs. We have natural gas in there as well, and we're currently working on a couple of hydrogen projects with a major auto manufacturer. The big thing for us is when we look at alternate fuel adoption, California is unique, right? What we don't know is what it's going to look like across the nation. We have a level of enthusiasm that isn't mirrored in many other places, but we also have an emissions issue that isn't mirrored in many other places. So it is the round peg in the round hole that we're working on right now, right? In our communities, in our state, this is a very important topic and one that we should all be working on. Now, when you look at PHEV, EV adoption, the big thing for me is when you're starting to look at the battery technology right now, when you're starting to look at the capabilities of the vehicles being offered, and you look at the adoption rate of battery electric vehicles versus the standard hybrids, the PHEVs and standards, the ramp rate is much, much higher, the acceptance rate much, much higher. Now, part of that is because of this. When you look at over the last couple of years, and it has been only a couple of years when you think about it, it's kind of amazing from no models just a handful of years ago to some 38 or 39 different models by a series of manufacturers. This is the wave of the future. It's starting here. It started here in California. It is going to be the way the country goes in different applications. But it isn't a toy anymore. It isn't a game. This is real, and it's real in the industry. When I look at this, it really is about the cost of the batteries, right? The cost of the batteries, initially we got over the concept of range anxiety. I mean, every fuel has a certain range that it goes, and then you have to refuel. In the pure battery version, initially, it was relatively short. The batteries were big, they were heavy, and now you're seeing that technology becoming much smaller batteries, much lighter, allowing us to put larger capacity on board. But when you look at it, you know, it is about the battery pricing. As that battery pricing goes down, just a few years ago, we were paying $1,000 a kilowatt hour or more. You know, we're to the point now, we're probably around the 350 range. We hope to have that thing closer to 200 in the next 18 to 24 months. As that goes down, think of something, I'll just pick any brand, a Chevy Volt, about a 15 kilowatt hour battery. You know, 5 years ago or 4 years ago, it was a $15,000 battery. Today, it's more like a $6,000 battery. We hope 2 years from now, it'll be more like a, you know, $2,000 battery. All of that is going to go right into the price point. You know, it is when you look at this, the capabilities are broad. We're not limited to any particular vehicle type. Many people think that alternate fuels are this hokey little thing. It's a real super dynamic, these little tiny cars, and I'm telling you, it's not. We've got them in everything, all the way up to our Class 8 vehicles. You know, in our service territory, this is the important part. One of our territory is just north of Los Angeles to Oregon. But when you look at the adoption of those technologies in our service territory in California, it is staggering compared to the rest of the world. And when you look at, particularly in the Bay Area, EVs are a big seller in the Bay Area, right? And I'll say electric vehicles of all types. When you look at the state, we're the top consumer in the nation. When you look at the Bay Area, we're the top consumer in the state by a long shot. So when you look at this, you know, we kind of look at the market share and how that's growing each and every month, and the adoption rates are higher and higher and higher. They are moving, they move from pure hybrids into plug-ins. The battery electrics kind of fell behind. Now the battery electrics are actually taking a bigger and bigger piece. So what we're seeing now is that range of the Tesla with the new Chevy Bolt that's coming out, with some of the other ones starting to get up in that 200, 250 mile range at an acceptable price point for consumers. You're seeing more and more of those being adopted. You know, I'm not going to spend a lot of time, but these figures, when you look at that map and you look at the density of those products in exactly where we live, that's why this is a big deal to us. It's a big deal to us as a consumer, it's a big deal to us as a resident of the area, and it's a big deal to us as a utility. As a utility, all of that electric demand is a big demand on the grid. It's a big demand on local circuits. You know, somebody asked me the other day, well, can you explain to me how that works? And I said, well, I'll give you my best shot to make it practical. So I have a house full of daughters. Let me tell you what, when they turn on curling irons, straightening things, all the things that young ladies use, they tax the circuit in my house, right? It's the same thing for a utility. It's just a bigger circuit, and you're putting a bigger curling iron on. It's called an EV, right? So the reality is that locally we can have challenges if too many cluster in a particular area, and it may mean we need to work on that circuit or upgrade it. Globally, we can take a lot of EVs onto the system with no incremental generation of electricity, but as you get into that local circuit, there can be challenges. So our technology strategy is we use a combination, you know, I like to tell people we work on the round peg, round hole strategy. In some applications, an EV is perfect, but what you don't want is your utility, your electric utility, run all EV vehicles. Because when the lights go out and there's no electricity, nobody's coming. I mean, this is an important thing, but these are things that we think about, right? So we have to have that traditional fueling infrastructure. When you think about catastrophic emergencies like Hurricane Sandy, we responded all the way from California to New York to work on Hurricane Sandy. That infrastructure doesn't exist on the East Coast. So that mechanism for sharing utility resources across the US and North America has to understand it has to be fuel sensitive for the entire operation, just not using it locally. So our goal is to look at these things differently. I did this chart a while ago, and it's been in the industry for a while, but we looked at all of the different fuel types at the time. We looked at all of the goods and bad things associated with them, whether it be, you know, range limitations or EPAC credits or all of the things, you know, the cost of doing business. And what we found for us in our application, this will be different for other people, is when you look at that PHEV line, it hit almost every category for us. It allowed us to operate in all-electric mode the vast majority of the time while still allowing us to switch to the traditional fueling infrastructure in the event of an emergency. We looked at CNG with some limitations on range. Didn't give us the same range for the vehicles, not range as in mileage, but range as in how far we could go when something bad happened. So this is an important thing for us. And our fuel strategy thinks kind of like this: how we use each one of those fuel types in our application and the things that it does and doesn't provide for us. You know, I keep telling people, why is the time now? And much like Jorg said, I don't know if global warming is real. It seems, I'm not a scientist, right? I build trucks for a living. But what I do know is it doesn't matter if you believe in it or not. What if it's true, and what if we do nothing about it, and what if we're wrong? The end seems pretty catastrophic, right? So our goal is to look at all of the reasons. There's tons of reasons, regardless of whether you're an environmentalist, whether you're one of these people who believes that's a big transfer of wealth from the US to other countries, whether it's the military needs to keep supply lines open. There are so many reasons why making these changes are good. It fits, for most people, one of those reasons or more. Electrification, we've seen a lot of things, right? Aside from, everyone keeps trying to make the kind of the payback on fuel. We've seen a lot of other opportunities from that. Aside from fuel savings, we've seen making our crews more efficient. We've seen our customers being more happy because we're not running this big diesel engine outside their window at 3 in the morning. I can tell you that's a big deal. I get lots of calls on that. But there's a lot of reasons why this is the right thing. Now, the value to PG&E is across the board. It's not one item, it's a lot of items, right? And I said a minute ago, there's a lot of vehicles out there that are electric. Every one of these vehicles is an electric vehicle, right? This isn't about the little car anymore. This is about the big truck. This is about aligning the right technology into the right vehicle and making sure that we're providing the best things for our consumers and our constituents, okay? So with that, I'll be happy to address any questions with the rest of the panel members. Thank you.
All right, we're doing well on time. We've got about 15 minutes for questions, so anybody want to know how to implement alt-fuel vehicles into your fleet? Yeah.
Yeah, I'd like to know if the gentleman from PG&E can speak to their experience with renewable diesel, given their leadership with alternative.
Well, I can tell you, we buy about 1 million gallons of bio or renewable diesel a year. We generally run that in a blend of 20%, B20, if you will. And our experience of late has been great. I will tell you, if you look back 5 or 6 years ago, it wasn't great. The quality of the product coming out 5 or 6 years ago, it was new, and it was something a lot of people didn't know about. What we found is we had some suppliers who were great, and the quality was great. We had some where it was being blended where they were great or they weren't great. And we had some of our own facilities where we were great or we weren't great. Many times it had to do with managing your own tanks and how clean your tanks were. That was what we found to be the biggest and the toughest thing to manage was us. It wasn't the supplier base, it wasn't the quality of the fuel. Once we put the controls in place to ensure that we were getting good quality fuel from our supplier and through the blender and to us, then it was all about us doing our job well. And once we figured it out, it hasn't been a problem in years.
I just need to say that response refers to traditional biodiesel.
Mhm.
I said renewable diesel, and I think it's really important that we all understand the distinction, and maybe I should defer to Pat or Pete to comment on that, because it's a totally different product, and it's really important that people get that.
Yeah, Dave's answer was actually perfect as it relates to their experience with B20, which I'm familiar with their experience with B20 as well. I don't know if PG&E is using R20 at 2 sites just as a testing, just so you guys know. So, but primarily still uses B20 for their diesel fleet as an alternative fuel. So I don't know if he could necessarily answer that question properly because the PG&E hasn't, to my knowledge, isn't using RD99 yet anywhere.
I guess it's just important to emphasize that the problems you identified
Yeah.
do not apply to renewable.
That's a great point. Yeah. So by switching to renewable diesel, that would never be an issue anymore to think about because the tank, keeping your tanks clean and proper and fuel filters proper and all those were biodiesel issues. That's the whole reason why we brought renewable diesel to the market because I was dealing with those issues for 13 years and I got tired of it. So you're right. I mean, it's a good point. It's why renewable diesel is doing so well, and we've converted pretty much all of our B20 business to RD99.
Yeah.
I have 3 questions, and one for each panelist.
Well, you need 4 then.
One for Pat, one for Jorg, and one for Clay. I'll start with Pat because I just wanted to follow on to this one. I'm wondering if somebody orders RD99 and wants to mix it in C2 with existing ULSD, if that's an issue. So if you have a storage tank or an in-vehicle tank that has a certain amount of residual ULSD in it, if you pump RD99 into it, are you going to experience issues?
No, not at all. I mean, they're on a chemistry basis, they're the same, so that it's just mixing two diesels together that came from different feedstocks. So you can go back. That's the beauty of renewable diesels, that because it's the same, you can go back and forth. So if you switched to renewable diesel, and now you're talking just a vehicle's tank, and it's been running renewable diesel for a month, and now you drive to Utah or something, and you need to buy petroleum diesel, there's really no reason you can't do that.
And can I ask another, or do you want to?
Yeah, go ahead.
Yeah, so to Clay, for the projects that you've been working on, obviously looking at the V1G, the V2G, and then the stationary storage, I mean, each one of them comes with different dynamics in terms of cost effectiveness and scalability. So I'm wondering if you could talk about what system parameters kind of define which strategy is going to be most feasible and cost effective, because V1G is not going to be effective for peak shaving in a lot of large scale applications, whereas you may need to consider stationary storage. And then similarly, if you have a vendor that's able to provide you a sufficient number of V2G capable vehicles with a software platform like the one you're developing, I mean, there's a very significant kind of capital cost barrier to deploying a strategy like that. So I'm wondering if you can talk about, X number of vehicles with an existing load profile leads you down a certain path towards kind of facility grid management using a kind of software algorithm like the one you guys have developed, and kind of how you tailor that to a client's needs.
I studied physics. I don't have a PhD in economics, but I'm going to give this a swing. So first of all, let's start with the demand response mechanism. Yes, we have a spreadsheet that calculates what is the demand response capacity based on the shape of the curve that exceeds a certain threshold, and how many dollars, that's $1.80 per kilowatt hour penalty per month. And then I can say, what is my cost of static storage? And in our case, the first deployments are using second life batteries, which has an economic benefit over even the current curve of what the actual cost is. So yeah, there's a real number. And I could show you graphs in some of these deployments where I could say, well, you can afford 20 kilowatt hour battery to reduce your charge by more than that cost with a return on investment of 3 years. That one's more straightforward. Unless and until utilities decide to get rid of demand charges, just for an economic curveball. So let's see what happens. Second one, so just straight V1G, oh heck yes. I mean, the physical infrastructure in EVSEs to charge is incredibly expensive. Google has 1,300 chargers on their campus with 2 hoses, so they can do 2,600 cars. It's not enough. And the cost of that physical infrastructure is almost unimaginable. So unless perhaps you're Google. So if I look at that and say, okay, I want an economic benefit to enhance my asset utilization, I could give you a spreadsheet showing you that if I deploy an app that gives me 2 charges a day per hose instead of 1, voila, here's my economic benefit. The third part of your complex economics question is even harder. And I'm going to defer that one to the bigger picture. Okay, you say V2G, if I had enough batteries, and obviously energy storage is the single sector in the energy industry that's been growing aggressively. If I had enough batteries, I could alleviate the duck curve. I could integrate more renewables. I could do wonderful things. Okay, fine. What is the economic justification independent of SGIP subsidies and venture capitalists paying for it? It's even at current battery costs, a little bit of a stretch. So I look at the bigger picture. If you look at the entire American electrical utility industry and you project what happens when distributed energy renewables are put on the grid that they do not own or operate, there could be a $40 to $50 billion revenue shortfall over a decade. Oh my. So now we have Thomas Edison meets the Big Short. Well, I'm not a utility. I'm not going to change the models. The utilities and the regulatory models are going to change who owns photovoltaic, who owns it on the house. What is it, a utilization ratepayer mechanism? But I'm going to supply the technology and software for them to be able to monetize it. So, I think, yes, there's a very large gap market opportunity for us. But on the third one, I'm not going to say that right now, today, with 42 cars in the LA Air Force Base, I can buy those cars with the revenue in trading. I can't.
You had one more?
I did. I had one for Jorg, and it kind of follows on what Brent Jameson was talking about earlier today, in that the integration of plug-in electric vehicle technology to some of the medium duty and then kind of the heavier end of the light duty scale seems to be limited, and product availability seems to be a challenge. It seems like Efficient Drivetrains is trying to step into that gap and fill it. And so I'm wondering if DGS or any fleet was looking to use you guys as a vendor or one of your competitors, how quickly that you'd be able to scale to an order of, X thousands of units to be able to pump out, a light duty pickup, whether it be a conversion or whether it be an in-house build. Because there's a lot of fleets, I think, in this room and throughout the kind of public fleet sector kind of looking for some manner of kind of maybe class 2B and to 4 vehicle out there that would fit their fleet needs, but there's just not a lot of product available out there. And most of the companies like yours are taking existing chassis and kind of converting them or integrating them into a new chassis as a glider. And so I'm wondering if you could talk about kind of scalability and production volumes relative to the need that appears to be out there in that kind of vehicle segment.
Okay, yeah, thank you for the question. There was a lot of questions in the question, but I'll try to catch up. So first of all, our business model is we develop very unique drivetrain technology, and our customers are really the OEMs. We're not building the end vehicles. We've gotten very good at building vehicles because all of the OEMs that we work with, they need help building the first example because they don't have the culture or the experience in doing that. So we've built everything from sedans to SUVs to logistics trucks to work trucks, buses. Now we're doing port trucks. And the idea is to demonstrate the technology to the OEMs in real-world applications to create demand. And for us, 2014 was developing production intent designs. 2015 was getting them into vehicles to create market demand. And in a lot of cases, the OEMs are not interested in looking at a new drivetrain technology because there isn't a ready-made market for it. So in those cases, we've gone to end-user customers and worked with companies that are progressive in their views, like PG&E is an example. They're a leader in the U.S. So with the work, just as an example, the work that we did with PG&E to build Class 3, 5, and now 6 trucks, we've started projects with Peterbilt, with Freightliner. We're in loose discussions with Ford now about potential future collaboration. Our path to market, in China we're already in production and we're already working with OEMs. We're shipping drivetrains and they're installing and shipping. So that's really the market that we're going after. In China we'll start scaling up volumes this year and it's on legs. It's on its way, primarily in the bus and the SUV market, and then later it'll be trucks. Here in the U.S., 2016 is about demonstrator vehicles with the OEMs, so Peterbilt, Freightliner, Ford, and starting the certification processes. 2017, we expect to do limited volume production, but to get all the certifications in place. And then 2018 would be mass production. So that's kind of the track that we're on. And if we can accelerate it, we're really, really interested in doing that. So
I can weigh in just a little bit as well. Jorg is correct that they've done a great job in this space. But the pickup truck market is the biggest market in the U.S., hands down, both from a retail play and a commercial play. So in my case, I happen to have about 4,500 of them. I'm very interested in that space, in that plug-in hybrid pickup truck space. We are working with the major OEMs right now to bring those products to market because we want to buy them, quite honestly. And I think our experience is what you're alluding to is that most of the really great technology companies are technology companies. They're not manufacturers, right? They're not manufacturers of volume, right? They do a great job developing technology, building prototypes, proving the concept, and showing people like me why it's a great idea. But then we need somebody who can build them to scale and distribute them and service them and all of the other things, and that takes a major OEM to do that, whomever that major OEM is. So I think you're going to see a lot of stuff come out here soon in that space from the major OEMs. You know, and I say soon, I don't know exactly what soon is, probably looking at the next several years. But, you know, there are several projects being worked on now, smaller with OEM upfitters, you know, the Roushes and the Ricardos of the world, and to bring those vehicles out ahead of the normal distribution.
I can add to that a little bit. There's a minute here. So we actually started off by building Class 2 vehicles. Those were our first implementations. And for the U.S., we made the decision to concentrate mostly on Class 3 and above, so light, you know, heavy duty, medium, and heavy duty. And the main reason is that we expect the OEMs to get into mass production on those smaller vehicles. Companies like GM and Ford will have their own solutions ultimately. So if you start a company and you start developing that area, eventually you're going to collide head-to-head with GM and Ford. So we're working in the areas that they're not working in, and that's kind of our strategy. In China, we're doing everything from very large to very small vehicles.
We have time for one more question over here.
David, do you expound on your view of your fleet as a strategic investment and how you look at total cost of ownership and life cycle analysis as you budget with the state of California?
Sure. So PG&E is a regulated monopoly, right? So we don't set our rates, the state of California does. And what we have to do constantly is justify why we're spending the money and what the best investment for the end consumers, us being the consumers of gas and electricity. Our view is that our fleet is an asset, and that when we can look at different ways to count, we do that. Most people, like I say, do standard cost per mile management, and they say, gee, if I can reduce fuel, then I get this payback model. Well, we just view that payback model as much bigger. When we look at the ability, some of the work we're doing with Jorg and a couple of other companies are exportable power, utility grade exportable power. We can run a plug-in hybrid vehicle all day long. In the event the grid goes down, we can power the grid with that vehicle. We've already done it. We were running those vehicles today. Not in large scale, but they are running, they are working. And when we can do that, that's a I'm not going to say a revenue stream, but that prevents us from losing that load for the end consumer. We look at this and say, we look at that plug-in technology, it lasts longer, really, right? The life cycle is longer. And when the extending the useful lives makes it more cost effective, we have to look at that. So we look at this thing across all of the capabilities that it provides. When we look at the city of San Francisco, it's got a noise restriction, right? So after 7 o'clock, we can't work. With a traditional vehicle, with a plug-in hybrid bucket truck, we can work 24 hours a day. Our crews are more effective. They're more cost effective. It reduces our costs. So we take all of those different revenue and cost-saving streams, and we lump them all together into the business case for EVs, saying that it is way bigger than a fleet issue right now, right? It really is a way we do business. It's emissions, it's economics, it's fleet, it's all of those rolled together, and a lot of people don't view it that way, but we do.
All right, one more.
Sorry. It kind of follows up with this, but it's a question for Dave. You rightfully point out that electric vehicles are more expensive than conventional vehicles, but as batteries costs come down, that the purchase price will eventually reach parity. But the more sophisticated fleets like PG&E, and you know this better than anyone, aren't waiting for that day because they already know the total cost of ownership is less, can be a lot less than conventional vehicles, including, so I do detailed total cost of ownership analyses, and people haven't thought about ways that they could save money. Gave a great example with the noise ordinance and avoiding breakdown costs and going out the next day. and there's a lot more. But when I go into fleets, organizations, there's a lot of decision makers, and they all have different reasons for introducing alternative fuel vehicles in general, environment or public relation benefits. But if you make the economic case first, then that seems to be the best, most streamlined way to introduce clean technologies. So
We agree completely, right? I've done this business a long time, and you hit it right on the head. It's an economics issue, right? A lot of people are environmentalists as long as it's cost effective, right? Some are environmentalists all the time. Some worry about this as long as it's cost effective. Well, what I've seen in most operations people, like fleet people, we tend to be cost conscious first, budget oriented, right? So we need to deliver them the product that, number one, is cost effective, and number two is delivers all the environmental benefits that we want to see. And we're there today, right? We can make the case today very well that the small premiums that we're paying today, very different than 5 or 6 years ago, right? The premiums, the benefits are easily, we think, outweighing that premium now.
All right, well, I want to thank the panelists. This was a great discussion. Thank you very much.